Okay, hi guys. I wanted to give you some hints on how to do this lab. So the thing with this lab is that you need to do first the calculations and then you can do the experiment. So to do the calculations, draw a picture of the circuit and write the Kirchhoff laws. The current law is I1 plus I2 minus I3 equals 0. Basically, I1 plus I2 is equal to I3, but you can also write that like this: I1 plus I2 minus I3 equals 0. For the voltage laws, I do two loops. One is a big loop going this way, and for that equation, because I'm going this way, this comes as a -8 for this battery, and then +5 because this is the loop direction, and then -68 times I2 because this is I2, and then for this one you do +22 times I1. Now for this big outer loop, you can ignore the middle resistor. So that gives you the big loop equation. I'm just going to draw the big loop here so you can see it. The big loop looks like this, and it has a direction, and this is the equation. Okay? So you don't include this middle one for the big loop. And then you get another equation by using one of the smaller loops. I'm going to choose this small loop here, and I'm going to go in the same direction. And if you do that, you get this equation: -8 plus 33 times I3, because you have I3 in this branch, plus 22 times I1, because you have I1. Read the rules in order to understand the signs. The rules are in my lecture notes. But basically, the rules say that this is a minus when the loop direction is like this, and when you go from plus to minus, it comes with a minus. So it's all in my lecture notes in the folder. So now you need to solve these equations. You have three equations. This is one equation, this is the second equation, this is three. You have three equations and you have three unknowns. I1 is unknown, I2 is unknown. The way you can solve this is you can plug in values and solve for I1, I2, and I3. If you solve for them, what you get is that if you do the algebra, you'll get that I1 is equal to about 0.146, and then that's I1. I2 is equal to about 0.002, and I3 should be equal to I1 plus I2. That's equal to about 0.000, sorry, 0, equal to about 0.1, sorry, let me check that. Let's see, to about 0.148, right? It's equal to about 0.148. So I3 is about 0.148. Of course, this is all through your through your calculation. And you have to go and set up this circuit, okay? If you set up the circuit on the experiment, you have to do that. You put in the ammeters. You'll see that I2 is 0.02. That's like what we said. But I1 is only 0.14 instead of 0.146. And I3 is 0.15 instead of 0.148. So there's a small difference because there's only 2 digits of precision here. So it seems to have rounded it. So that means that there's some approximation, but it basically works out to what we said. And I put in some voltage meters. You can check the voltages going around and see if they're the same as if they all add up to 0 for the loops. As far as the figures of merit are concerned, really what they're trying to say is that don't worry about the figures of merit. That's not so important. All they're trying to say is that if you look at this equation, percent error, you can define it like this. as 100 times I1 plus I2 minus I3 experimentally, you can experimentally determine this. And then you can divide it by the value of, the value of absolute I1 plus I2 plus I3. And usually they, they divide this by 3 sometimes. You don't have to do that, it doesn't really matter. Include this factor. But anyway, this thing on top is supposed to be 0, but when you actually do experiments, there's some error. And like if you go to the picture, you have, if you take the I3, sorry, this plus this minus this, you don't actually get 0. You get 0.14 plus 0.002. That's minus this. That's, if you subtract, it doesn't become 0 because there's some lack of accuracy here, right? It rounded, it did some rounding or something. It didn't exactly get it right. It's not all adding up to 0. So, because if you add this, you get 0.142, you don't get 0.15. And that's just due to some, rounding errors or whatever. And you don't really need to worry about that, but the point is that Kirchhoff's current law and Kirchhoff's voltage law, they might not work out exactly, but they're generally pretty good, and this is a way to characterize how close you are. But you can't really do that unless you actually do the experiment, so let's not worry about these merit figures of merit formulas for this lab. So you don't need to worry about those. Um, so that's all I have to say. Please let me know if you have any questions. Thank you.